Hello students, welcome to ePhysics. Students, in this video we will be discussing the NCERT solutions of class 11th physics chapter waves. In the previous video we have discussed a few questions and we will be starting this video from the part where we left in the previous one. So let's start it. So the first question is in the screen, students. A bat emits the ultrasonic sound of frequency 1000 kilohertz. So the frequency has been given, that is 1000 kilohertz. So we know the unit of frequency is hertz, so let's convert it into hertz. That is 10 to the power 1000 can be written as 10 to the power 3, and kilo can also be written as 10 to the power 3 hertz. Okay, so finally this can be written as, the base is same, the powers will be added, 10 to the power 6 hertz is the final frequency. Okay, now if the sound meets a water surface, what is the wavelength of the reflected sound? Okay, wavelength of the reflected sound. Students, the first part of the question, it is asking the wavelength of the reflected sound. So wavelength of the reflected sound, we know the formula of wavelength is equals to velocity of the wave divided by the frequency of the wave. So since it is the reflected sound, it means the wave is coming back into the same medium through which it was traveling initially. Okay, and initially it was traveling through the air. Okay, initially it was traveling through air, and after reflection it will again travel through air, and the velocity of the light wave in air has been given, that is 340 meter per second. So it can be written as 340 divided by 10 to the power 6. Okay, so itna meters. So when we solve it, we get it is somewhere around 3.4 into 10 to the power minus 4 meters. So this is how we solve the first part. Okay, now the second part is the transmitted sound. Transmitted sound means the wave has traveled from one medium to the other. Okay, from one medium to the other. The first medium was air, okay, and the second medium, it is saying it was water. So second medium was water, and we were supposed to be finding the wavelength in the water. So wavelength of the transmitted wave, wavelength of the transmitted wave, again the velocity in water, because the transmitted wave is in water, divided by the frequency will be same, of course, we have discussed it. Now the velocity of wave in the water is 1486 meter per second. So this will be equal to 1486 meter per second divided by frequency, that is 10 to the power 6 meters. When we solve it, we get the answer, that is somewhere around 1.49 into 10 to the power minus 3 meter. Okay, so this is how we used to solve these kind of questions. Okay, now you can see it. Now let's move to the next question. Again, students, the next question is in the screen. An ultrasonic scanner operating at 4.2 megahertz. It is hertz over here, it means it is frequency. Okay, so this is equals to 4.2 megahertz. Okay, now we should convert it into hertz, because the unit of frequency is hertz. So this can be written as 4.2, and mega means 10 to the power 6 hertz. Okay, so this can be written as 4.2 into 10 to the power 6 hertz. Clear? Now, and it is used to locate the tumors in tissue if the speed of the sound, that is 2 kilometer per second. Okay, speed of the sound is given, that is 2 kilometer per second. So that is the velocity is equals to 2 kilometer per second, but the unit of the velocity is meter per second. We need to convert kilometer into meter, so we can write it as 2 into 10 to the power 3 meter per second. Clear? Now let's move to the next part. We are supposed to be finding the calculate the wavelength. We know the formula of the wavelength, that is wavelength is equals to velocity of the wave divided by frequency of the wave. The velocity is 2 into 10 to the power 3 and frequency is given over here, that is 4.2 into 10 to the power 6. Okay, itna meters. No, finally the answer after calculating we get it is equals to 4.76 into 10 to the power minus 4 meters. So this is how we solve these kind of questions. Now let's move to the next part. Now the next part is in on the screen, students. Question number 8. A transverse wave, harmonic wave on a wire is expressed as, this is the equation of the wave. Okay, now the first part of the question says, is it a stationary wave or a traveling one? Now students, we know the equation of a progressive wave, that y is equals to a sine omega t plus minus kx plus minus 5, where 5 is the phase difference. Now if the wave travels from left to right, we take kx as negative, and if it travels from right to left, we take kx as positive. And here if we compare this equation with the general equation of the progressive wave, we can see that a amplitude is equals to 3, this is sine of course, omega is equals to 36, omega is equals to 36, let's write it, amplitude is equals to 3, omega equals to 36, and we have k ka value is 0.018, okay, and phase difference is pi by 4. And since this equation satisfies the general equation of the progressive wave, therefore this is not a stationary wave, this is a traveling one, that is this is a progressive wave. Okay, now if it is a traveling wave, give the speed and direction of its propagation. Direction is of course from right to left. Okay, direction is from right to left because we have positive sign over there. Okay, now what will be the next thing it is saying, if it is a traveling wave, give the speed. So speed will be equals to, we know the formula, that is lambda is equals to velocity upon frequency. And since we don't have velocity, we don't have the frequency, we don't have the lambda, so we need to find some other thing. We know other formula of to finding velocity, that is v is equals to omega upon k. Okay, remember this formula. Therefore v is equals to omega ka value is given, that is 36. Here we have compared it, 36 divided by k ka value is also given, that is 0.018. When we solve it, we get the value somewhere around 20 meters per second. Okay, now let's find its frequency and amplitude. Amplitude is already given, we have compared it as 3. Okay, now the frequency will be equal to frequency is equals to we know the formula, that is omega upon 2 pi. Okay, omega upon 2 pi. Okay, we know the formula for frequency, remember this formula. Okay, we will be solving many questions related to omega k velocity, omega 2 pi frequency. Okay, now omega ka value is of course 36, we have already found it, 2 multiplied by pi. Okay, 2 pi is equals to 360, we don't need to write it. Okay, just write it over here, and when we solve it, we get the value somewhere around 5.7 hertz. Clear? Give the initial phase at the origin. Initial phase at the origin we have found it, that was equals to pi by 4 according to the equation. Okay, according to the equation. Clear? Now calculate the smallest distance between two adjacent crests in the wave. Smallest distance, that is we need to find the wavelength. So wavelength is equals to, we know the formula, that is 2 pi upon k. So 2 pi upon k ka value is 0.018 meter. When we solve it, we get somewhere around 249 centimeter. meters. So this is the way how we solve these kind of questions. Now let's move to the next question. Now the next question is on the screen, students. For the wave in the above equation, that is question number 8, the equation was y is equals to 3 sine 36t plus 0.018 x plus pi by 4. Okay, this was the equation that has been given. Now plot the displacement y t graph for x is equals to 0, 2 and 4. Now students, I will not solve it. I will just give you a hint how these kind of questions are solved. Now when we are asked to put x is equals to 0, so let's put x is equals to 0 first. Then y will be equal to 3 sine 36t, and 0 multiplied by anything is 0, therefore plus 0 plus pi by 4. The final equation becomes 3 sine, okay, 36t plus pi by 4. Now next thing is we need to put x is equals to 2. When we put x is equals to 2, we get y is equals to 3 sine 36t plus 0.018 into x ka value is 2 plus pi by 4. So and similarly we need to put x is equals to 4 once. Okay, so we will be putting x is equals to 4 and we will find the values. We will create the table and then from that table we will be drawing the graph. Okay, we will be drawing the graph and hopefully you get it and you will solve it by yourselves. So now let's move to the next question now. Now students, the next question is in the screen. A traveling harmonic wave is given as y xt is equals to 2.0 cos 2 pi 10t minus 0.0080x plus 0.35. Now students, first of all we should solve it like we have to remove this 2 pi. So let's put this 2 pi inside the bracket. So finally we will be having y is equals to 2.0 cos, this 2 pi multiplied by 10t becomes 20 pi t minus this 2 pi multiplied by this part becomes 0.016 pi x plus, and again 2 pi multiplied by 0.35 becomes 0.70 pi. Clear? And here we have like we have the value of a is equals to, that is amplitude is equals to 2 centimeter, and we have the value of k is equals to 0.0160. Okay, and similarly we have the angular frequency. Of course, the angular frequency, that is omega, is equals to 20 pi. Okay, 20 pi radian per second. And now let's solve it. This is pi, I left it, sorry. Now so we have to find the first part is what is the phase difference between the oscillatory motion of 2 points separated by a distance of 8 meter. Okay students, we know the formula of phase difference, that is phi is equals to kx, or it can also be written as 2 pi upon lambda. So since we have the value of x given over here, so we will be using this formula. If the value of lambda, okay, had been given over there, we would have used this formula. So since we have 8 meter, so phi is equals to k ka value has been given, that is 0.016 pi multiplied by 8 meter. 8 meter when converted into centimeter becomes 800 centimeter. So finally we get the answer 12.8 pi radian. Okay, so this is how this part is solved. Again the same thing is given over here, so we will be using that same formula. Phi is equals to k multiplied by x. K ka value is 0.016 pi multiplied by x ka value is 1 meter. 1 meter when converted into centimeter becomes 100 centimeter, which is equals to 1.6 pi radian. Clear? Now it is lambda over here, so we can use that next formula, that is equals to phi is equals to 2 pi upon lambda. Clear? 2 pi upon lambda. So this becomes phi is equals to 2 pi, and the lambda is equals to lambda by 2. So this can be written as lambda by 2. So this becomes, sorry for the inconvenience students, okay, this will be multiplied by lambda by 2. Sorry, that was my mistake. 2 and 2 gets cancelled, lambda and lambda gets cancelled, so this will be equal to pi radian only. Now this is 6 lambda by 4. Now for this again phi will be equal to 2 pi by lambda. Okay, k ka value is 2 pi by lambda into x, so this will be equal to 2 pi by lambda into x. X ka value is 6 lambda by 4. This lambda lambda gets cancelled, this becomes 2 and this becomes 3. So the answer is 3 pi radian. So this is how we solve these kind of questions. Hopefully you understood it and you will apply these things to solve the numericals and the other questions. And I hope you understood the video very nicely. So thank you very much for watching the video.